Now I will quickly run through the bronze layer ingestion that we have done on last week for one of the external data. Okay, it is coming from the API and we did it how to ingest the data from external API into our data lake storage account. That was the one that we did it in last week. I quickly run through it because we are going to transform this data today, how it will be loaded into the silver layer. So to everybody in the same page, I would like to run through this notebook only one time quickly so that everybody can able to follow it, how this will get transformed in the silver layer. Okay, my data is existing in one of the API URL. This is the URL. Obviously, your external data, if it is existing outside Azure, somebody need to provide this information to you. Which API you need to use, what is the base URL for that API. So it will come to you. So one of the way to get the data from the web API into the Databricks, not even Databricks, is Python variable is, Python has got the request library. Okay, request is basically to make a request to one of the web URL, and whatever the web URL will return it can be stored in the Python variable. In this specific instance, the data going to come back from this API URL is JSON. So I am trying to import the JSON library as well inside the Pyspark. So we have got this one. Now there is no Pyspark code involved yet because Pyspark can't able to reach out this URL and can able to read the data as a data frame. That is not in the Python libraries, sorry, Pyspark libraries. So I am using standard Python request and one of the method get. I am passing this source URL and I am getting the data in the JSON format. Again I am storing that in the Python variable. This is the Python variable. That is the one of the very specific thing you need to aware of that one. You need to understand the data flow. If you understand this one, for any type of the data you can able to write the Pyspark code. Okay, now the return format from this request.get will come in the HTTP format. I know that the return data definitely comply with all of the JSON format. That's why I'm using another Python library JSON. I'm dumping all of this data coming into the another Python variable. Now it's becoming the JSON Python variable. Okay, the data type of this Python variable is JSON. Until here it's not JSON. Even though I'm giving here JSON, the request, whatever the response will come from that web URL, it is stored here. Here I am converting into the JSON data. Now I need to convert, this is my source data. I need to convert this into the RDD or a data frame. Actually, originally my objective is I need to convert that into the data frame, but still Pyspark can't able to directly read this and convert into the data frame because Pyspark always store the data in the arrays. Okay, the list is the default storage for any of the data frame that we are talking about it. Hopefully at least one place, yes. If you look at this data frame, if you look at this opening bracket and square bracket, that means it is storing in the arrays. So what I am doing is that I am storing my JSON data into the array. I am using the array function called append. So it will store the data into the array. The JSON data is stored inside the array. If multiple JSON documents are there, each are separated by commas. Okay, now again I have not yet gone to the Pyspark variable. Now what I am doing is that I am passing this array value to the Spark context. Here I can't able to use the Spark session because Spark session will work only on the data frame or table. Whenever the external data is coming in the RDD format, only Spark context work. Probably for Amar, this is also another example where we need to use the Spark context. If I say parallelize, that means inside this JSON data, I am converting the RDDs are always the parallel chunks of the data. Okay, so when I am converting my external data into the RDD, I need to use the parallelize function and pass the JSON data. This one will return the data as a RDD. Now my source data. Here Pyspark code is started, in fact, okay, the low level Spark context code is started and it become the Spark RDD. Now if I use the Spark read, this is, we know that this is JSON format, okay. The RDD can be converted into the data frame because the data frame is developed on top of the RDD, okay. That is the compatibility is here. So now I am using the spark.read. This RDD's original format is JSON. That's why I am using the JSON and I am passing this RDD, okay. Another one work here as well is spark.create data frame. You can directly give this source RDD. This one will also work. Both are similar functionality, but I want to have some compatibility with what is the data we are processing it. I need to have some relation to original JSON data, how it would converted into the data frame. Now I have got my external data as my Pyspark data frame. Now I can able to write this the JSON data into my branch layer. This is again external data. The first layer ingestion I am doing it. So I have given the folder name for this one and I have write it in the JSON format. This is how we need to bring the external data. External data in this case in JSON format. If it is in the CSV format, the similar step you can able to use it. Instead of using the JSON library, you need to use the CSV library and you can able to use every step the same way and you can store it as a CSV file inside the Azure Data Lake storage account. So output of this notebook is coming to the branch layer geocoding. Probably I will go here. All of them are existing in Data Lake House. Branch layer geocoding. It is stored in the JSON file format. Okay, this is the actual API output. Some of the files are empty files. Don't worry about it because it is distributing the data across multiple clusters. We have got reasonably very small amount of data, so it didn't go to some cluster. The cluster they didn't get any source data will create the 0-byte JSON file. Don't worry about it and don't confuse it. This is the original JSON file. It's coming from this API and we stored it. Definitely there are 10 records are there. Now we try to read this file again in the another notebook because in the branch layer it's coming with little nested structure. It's not too bad. Okay, this is the first column and the results is the another array and it's storing all of the values. If you want to flatten this one, you need to use the one of the function available in the Pyspark to use it. But in this case, probably if I take this one, it is only one layer of nested. Okay, the square bracket is it's starting, the only one square bracket is closing here, only one square bracket is starting here. It will be little straightforward one, but still we need to flatten it because flattening the JSON file is one of the general transformations we do in the Silver layer. There will be the better example for Silver layer if your source data is JSON is flattening your JSON data. What is flattening? We will be seeing it shortly. So what I need to do is that this is where I have written my branch layer. Okay, I'm going to my workspace. I'm going to create the one Silver layer transformation on top of my source data. I'm going to create the new notebook. Create new notebook. Okay. (02). This is specifically we calling it as geocoding data. Okay, and I will just copy paste that variable path. Okay, this is our source path. This is where we ingested as part of the API ingestion code. Previous code ingested the data here. Now I would like to read this data. This data is in JSON format. Okay, and I just given the path of this folder. Okay, my compute is stopped. So this is existing inside the data lake storage account where the Spark session have got the direct access, but this data set is not yet converted to the Pyspark data frame. So we need to use the one of the Pyspark function now to read the data from this data that's been ingested in branch layer. Can anyone tell you what is the Pyspark function I need to use it to convert this into the data frame? No? This is not the external data. This data is existing inside the data lake storage account now because we used the previous notebook to bring the data into the branch layer in our data lake storage account. This is just pointing to the path of that folder. Now I want to convert my this source JSON file into the Pyspark data frame. Okay. Perfect. Exactly. Okay. So now and other thing I need to always do is that branch geocoding source df equal to this one. Now it's converted into the data frame. Probably I will trying to ask you the question and trying to write the code here so that you slowly getting used of this one. Okay, now I will just display this data frame value so that we can able to see what values are there and what values we are interested in, so that we can able to process. Okay, so it's little small. I try to expand it. Okay, there are two column names are there at root level. One is a generation timestamp, another one is result. The generation timestamp has got the straight away timestamp value. There is no complex data type, but results has got the array of values here. Okay, it has got array of values. So if you want, we are interested in, okay, we are interested in this first column called admin1, okay, and admin2, admin1 ID and admin2 ID. This is the geolocation values. This basically latitude and longitude of the market name that we are interested in, the pricing that we are doing it. Okay, so I think probably I need to put this one somewhere else, otherwise it would be little difficult to explain it. Okay, I'll copy this one. Okay, this is looking better. So the generation millisecond is the separate column. The results is the array value. It's starting here and it's ending it here. And inside the array, there is one dictionary per same market name, which is having the match. Okay, the original API that I have sent is trying to get the latitude and longitude information of the specific market name. Okay, this is my specific market name. Okay, for this market name I need to get the population. Okay, that is the one of the value I am interested in, because this will affect the prices selling in that market directly. This is my market name, and on top of that I need to know latitude and longitude information, because this is the information I subsequently need it to get the weather information of this market name. This is what we are originally trying to get it. Hopefully correctly entered it, country ID. So from this I need to know, probably I am interested in which state it's coming from, because later part, if the same market name existing in the different state in India, I want to differentiate it. And I'm not interested in this admin1 ID and admin2 ID. I'm interested in the admin 2. This is the district name of that market that I am interested in. And then probably I'm interested in latitude and longitude information from this JSON file. That's all I'm interested in. Even I'm not interested in the generation time. Okay, so we keep this window. We try to do one by one. Let me see how it plays. Okay, I will take back this explode and try to explain why explode is needed. Okay guys, so that will give them. Okay, my source data is stored inside the array. My assumption, actually, I thought actually if it's not a nested array, I can directly use the root array variable and inside the array variable. But what is happening here is this results array has got 10 different dictionaries. If you look at it, it has got 10 different dictionaries. So 1, 2, 3. This is all individual dictionaries, okay? And array is ending only there. So this is the array starting point, and inside this array there are, I think, 10 elements are there, okay? And if I just select results.admin1, there is only not one element is there. There are 10 elements are there. So it's giving all of the values from that admin1 inside another array. Okay, that's what happened previously. If you do just results.admin1, if I display it here, it's displaying the all of the admin values coming from into the another array. But originally what I need is I need to come out of this array. It need to be displayed with the actual physical column values. The flattening is basically converting this nested structure into the plot structure. Okay, that's what we are aiming to do. So they are asking to use the function called explode. Okay, what explode does is that here it's giving in the one array value. Inside one array there are 10 elements are there. The explode function, what it does is that it will convert this array data type into string data type. It will traverse through each of this array. Each comma separated values will coming as a one column name value, and the column header is going to be admin1. So keep this in the mind. Now as soon as I give the function called explode of and it's going to explode this array into the individual column name values. One of the closing bracket I missed. So you see that it is giving all the 10 elements inside the array into 10 different rows. Okay, the similar explode we can able to do it for the remaining column names that we are interested in as well. For example, the admin2 we are interested in, that is the state name. The first one is state name, the next one is the district name, the next one is we need the market name, and the next one is we need the latitude and longitude information. So we'll do one by one separately, then only I think I can able to explain it very quickly. Otherwise it will create the too many confusion here. Definitely I think I need to do them one after another. Yeah, I need to do one after another. Okay, now while exploding this one, it has given the default column name called call, and if I want to change that column name into specific thing that we are looking at, for example, I can able to give the state name. So as soon as you give this one, it will display the state name value, the column name becoming the state name. So what I need to call this data frame as, okay, bronze state name df. Okay, that is the first column name that we have selected it. Now the same one I need to select the district name as well. The district name is existing in the admin2 column, and if I change it into the admin2 here, and if I say district name, then we try to display only this one now, because previously we displayed the state name and we are converting this into the district name. Okay, now it's displaying the district names. On top of that, we are interested in latitude and longitude and the name. Okay, the name column is the market name. Okay, latitude and longitude and the name column name is a market name. So I will do that one. In fact, for latitude and longitude, I don't need the alias. The same name will do the and each of the data frame that we are giving it, make sure that it works fine. Yeah, latitude is coming. Another one is longitude. Better I copy that one. I'm not sure about the spelling. 1 minute guys, I will be explaining it very properly again why we are doing it. This is the one of the standard silver layer data transformation. Okay, okay, latitude, longitude, and the only thing I need is the market name. Okay, market name is existing in the name column name. Okay. So now we converted, okay, this explode function. I think you can able to identify why we have used the explode function, because our data is stored in the JSON format inside the array, and this array has got more than one elements. When trying to read the data from one of the column name inside the array, there are multiple values are returning, and obviously it's returning all of the values inside another array. We need to convert each of the values it returned in the array into the individual column name, because we need to store this in the flattened format. We do not want to store it in this complex array format. We want to store it in the flattened format, because we need to merge this data with one of the pricing data that we have got. This pricing data need to be merged with this data, and the join column name between this pricing data and that population and longitude longitude and latitude data is market name. That is the reason we are splitting everything into the individual column names. Now this is existing as a 6 different data frames. Okay, it's all related data, but these 6 data frames need to be joined together to bring the state name, district name, and market name, and latitude and longitude information. The 1-4 information that I am interested in here is population as well. That is the one I have a mistake. We will include that one as well. So I don't think it needs the alias. When the column names are not proper, then only we need the alias. Okay. Some of the values are coming as null. That's fine. Actually, that is the API return data. Only one market name properly. The population is coming. That is the market name we are specifically interested in because it's storing only the market names from the main market name. That's all. Forget about this null values. That is the API return data. So now we converted each of the column name existing in this results array into the separate data frames. Okay, not the single data frame. Yet we didn't bring it into the single data frame. Okay, so now if you need to join all of these data frames, for example state name and district name, you will take it out separately, so that will make sense. It's all related data. Okay, I will display them. And district name as well. Okay, if you look at it, all of the 10 rows has got the same state name. That is fine. But if you look at the first record in the JSON file, it is having, this is the Tuticorin. If you look at the second record, it is saying it as Dharmaburi. And if you look at the third record, it's coming as Pudukkottai. So first record in this transformed data need to be joined to the first record in this transformed district name. Okay, in the same way, in the same running number, these two things can be joined. Then we can create the flattened data for state name and district name. The similar thing can be done for all of the remaining 4 data frames as well, and we can combine together to have the flattened data of our complex JSON file. Okay, so to do that one, we need the running number along with that the transformed data. When transforming the state name, along with the state name, I need to have the running number. Depending on the number of records are existing in, you need to have the running number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In the same way here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then I can combine these data frames together and I create the flattened data. So to create the running ID inside the Python Spark, that is the one of the existing function called monolithically increasing ID. Okay, this is the existing function. It is existing inside the Pyspark SQL function. Okay, so I will explain little more detail about this one as well. Okay, for the time being I will include this one and I will show you how to join this data together. This is the existing Pyspark function. Why we are specifically using this function is, even we can generate the running number here, but if we generate the running number here, we will end up with one problem. The problem is that this code is going to be executed in the Spark cluster. That means the code will be split into multiple cluster nodes. One node is generating running number called 1, 2. Another node is generating 1, 2. The data will be duplicated. The running numbers won't be very unique. That is why Pyspark has given this specific functionality. Even though it's running in the cluster, it will generate the consecutive running numbers. This function is written on top of the another feature in the Pyspark called broadcast variable. Okay, this function is written using the broadcast variable. What means broadcast variable is, even though code is running on the multiple worker nodes in the cluster, the specific variable that you declared will be incremented consecutively irrespective of the cluster it's running. The first cluster created the value 1, 2. The second cluster, while creating it, it will check with the first cluster what is the latest value for that value, and it will start from 3 and 4. If you define that as a broadcast variable, that we will see little later part in the course, but this function is needed for us here. That's why I generated it. So now we will run these two data frames. You will be having proper running number. It is starting with 0. That is absolutely fine. Now we can able to join this data frame with this data frame using this ID column. Okay, so we are going to learn how to join one data frame with the another data frame using the join function. Okay, so we start to do that one. That's why I will remove this display one. Okay, so this one dot, now we are using the Pyspark functionality, join this one. I refer back the syntax. Okay, I'm not great at syntax as well. Dot join. Okay, and then comma, you need to specify the common column name between these two data frames. Obviously the common column name is dot id equal to, we are using the same column name in both of the data frames, so better we need say with data frame dot id. Okay, so here I'm specifying silver bronze data frame equal to, for the time being we are joining only these two data frames, but we need to do that one for all of the data frames. Let me say we how this the transformed data frame is coming on. Hopefully 1 equal to is right. Oh sorry, double equal to in the join condition you need to use the double equal to specify the join condition. That's why it's given the error. Okay, now it's joining the first row in the first JSON file with the to green first. Even we can take the last one, it will be joining with the last row in the this one with, it is joining with the district name Karur. So we can able to do the same thing for all of the remaining data frames. So all we are going to do is that in each of the data frame we are going to include this ID column starting with state name and district name and the latitude and the longitude and the market name and the population. We'll make sure that it runs fine. So these all are the steps depending on what type of the data that you got. In this case this will work. In the other cases, if some common column name is existing between the data frame, we can directly able to join it. For example, after producing this silver transformed data frame, when we need to join this one with the our main daily pricing data, the market name is the common column name between us. Market name and state name is probably the common column name between this data frame as well as this silver layer transformed data frame. So we can able to directly join it. So I'm going to replicate this one for each of the data frame that we have got. The next one is latitude data frame. So it would be better after each joining you are applying, in the first instance make sure that all of them are working fine, it's not giving the error. The same join condition, okay, only the data frame that you are going to join is going to be different. I think we can do that one because it's properly working. For remainder of that one, and one more join for market name DF. Sorry, that one is right. And one more join for population. I think we are there. Okay, now if we display the everything, so which one coming as call and ID? Okay, I think which one I didn't give the alias properly. Market name, ID. Okay, I think everything need the alias because it's giving the problem. I thought latitude and longitude and the population I can get away with the alias, but sorry guys, we need the alias, otherwise it's giving the default column name. I will change it quickly. I hope everybody is familiar with what is alias name at this point in time. Latitude and longitude, market name and the population. I'll run it this one. Now if I run it properly, all of them will give the column names properly. Yeah, all of them are giving. These ID columns are unnecessarily coming from the entire data frame. Obviously, we know that how to select the specific column names. Select state underscore name, comma, district underscore name, comma, latitude. Only one time I'll run this one, so only the selected columns are coming. We can make sure that. Very good. So comma, longitude. Is there anywhere I have given that one? Yes, longitude and the market name and the population. So that now we can write this one into the silver layer in our data lake house to store the transformed data. Ultimately, in the silver layer, we are getting the data prepared for producing the final output. Our final output is we need to merge this daily pricing data with the population and the latitude and longitude information, and also the weather information that we are going to ingest using the similar code. Okay, so this one silver trans df. Okay, I would like to silver write df equal to, I only need to select these column names. Okay, we don't need this closing bracket for the display function. Now if I define the silver layer path here, like we have defined the bronze layer path, and if I write this into the data lake storage account, we can write it in any of the format. So I'm going to say that silver geocoding folder, always it starts with the small case, that is the natural Python language naming conventions. So I'm going to say silver geocoding. This is the location for this one. Now if I write my silver write df into this path, probably we will keep it in the JSON format, okay, because original code also in the JSON format, but here we have plotted the complex JSON into the plain JSON. I'm shortly showing it to you how it is going to. Okay, after changing this select statement, probably I didn't execute it. If it says some variable is not defined, that means the code is not executed inside that notebook. Now there is no silver layer is here at the moment, but it's going to create it now. It's already created it because the code is started to run it. It finished it as well. Now if you come to the silver layer geocoding, if you look at your JSON file, this data is very flattened, okay, This was the original format of the data that we got it from API. It's little complex to work. Still we can able to make this code to join with our daily pricing data. That is possible, but the purpose of the silver layer is not making that one complex all the time. Not only this purpose, this silver layer data can be used. Any other purpose, for example, we need to get the weather data from the weather API that need to pass this latitude and longitude information. From this complex JSON file, getting that information and passing to the weather API is complex than getting it from this JSON file and passing to the weather API. It's very straightforward. All of the records are properly coming in the single rows actually, okay? And this data also existing in the same flat layer. So it will make our life easier. The ultimate purpose of silver layer again is making the further processing easier. While processing the gold layer, the processing need to be as easy as possible. Those type of the transformations only we are doing it in the silver layer. This specific case, this makes sense. In some cases, for example, from the source data that we are receiving it, the pricing information from one country is existing in Indian currency. From another country it will be in US dollar. In another country it will be in the pounds. What we do in the silver layer is we'll convert that into the common currency that business is looking forward for it. We don't keep it in the multiple currencies. Those type of the transformations we do it in the silver layer. In our case, we need to find it out what all are the factors affecting the pricing of this source data. So we thought we identified population data and the weather data plays a bigger role in the pricing of the products in India. So that's why we brought back the population and latitude and longitude. We specifically brought it in because we need to get the weather data. The weather API don't support directly market name. It needs the latitude and longitude information. So when we get the weather data, we will get the weather data into the bronze layer using the similar way of API that sometime before we have seen it. The same API to get the geocoding data, the similar code. Only thing it's going to change here is the URL for the weather data that I will provide it. You can bring data into the bronze layer. Again, it will be in the complex JSON data. You use the similar transformation that we applied for silver geocoding. You can able to use it for weather data as well to transform it into the flattened format. Then you write it into the silver layer. At the finally, you can able to write everything in the gold layer. Once you bring the weather data into the silver layer and you flatten it, you will be having 3 data with you inside the data lakehouse. The bronze layer is the plain daily pricing data. You do not need to convert this into the any other format. It's properly in the plain format. If any data you don't need to convert it, you don't need to roughly bring it into the silver layer. That is not necessary. You can able to combine bronze data with silver layer data to produce the gold layer. Without having any transformations, you don't need to bring that data into the silver layer. You bring it into the silver layer only the data to be transformed, to be flattened, to be consolidated, to be defined in the consistent format. Those type of the data only you bring it into the silver layer. So weather data, I will send you the API. You will be bringing into the bronze layer first, the similar coding standards, and you will be converting that in the silver layer to flatten it, and you will be bringing that into the silver layer. And at the end, we need to join our bronze daily pricing data with the silver layer geocoding data as well as silver layer weather data, and we produce the final output in the gold layer. It is going to be the simple join, okay? The market name is the common column name between the different layers, and we can join it. Already we have learned join here. So similar join functionality you are going to use to produce the gold layer. Probably we will see that in the next week lesson.